Welcome back to math class. This is Mrs. Witt. This is my Math 7 Accelerated lesson 14.2, so week 14, lesson 2. We're still talking about equations, but this time we're actually solving one-step equations. So let's begin by just reviewing and recalling some of the things we talked about in our last lesson. A variable represents some unknown value. A constant is a number. It stays the same. It never changes. It's constantly that number. An expression is a group of characters together, like it can have operations or numbers or variables. It can have all of those things, but it represents a specific value. An equation is that expression set equal to something. A solution is a value that makes it true. And I'm taking it way back to the beginning of the school year. What is an additive inverse? Well, an additive inverse, remember, it adds up to 0. We thought about it as being the opposite number, the opposite integer. So like additive inverse of, let's say, 7, its additive inverse would be -7. Okay. So let's take a moment and I want you to think about these things. If x plus 7 equals 10, then the value of x should be, and there's 4 of those, and I want you to just take a moment and think about that, and then we'll come back together. Okay. So I'm hoping that when you looked at this, you said that the value of x, when you take x plus 7 equals 10, that it should be 3. X minus 7 equals 10. I'm sure you reasoned that to be 17. 7 times x equals 70 would be 10. And x divided by 2 equals 10. Well, that would give us to be 20. So how can we find the solution to those equations? How did we find the solution to those equations? Well, let's go back and look. If I'm looking at this and I'm considering, what did I do to get 3? Well, right now I know that there's something added to 7 that gives me 10. So what I'm really doing is I'm finding the difference. I'm subtracting right there. Because if I said 10 minus 7, well, that gave me 3, and that told me what that should be. And here I'm subtracting, but if I look at it and if I were to add that 10 plus 7, well, that would get me 17. And here I'm sure you found 10 by dividing. If we take 70 divided by 7, that gave us 10. And then finally, on that last one, you multiplied. 10 times 2 gave you 20. So for every one of these things that we see, like here it was a plus, but we subtracted. Here it was a minus, but we added. There was an understood multiplication, and we divided. And there's division, and we multiplied. So how can we find a solution to these equations? We didn't do the operation that was listed there. We did the inverse operation, right? Which is kind of like the opposite. It's like the undo. So let's define. Let's start with that bottom one because we just talked about it. What is an inverse operation? It's like an undo button, right? It is the opposite operation, and it will take you back to where it started. It will undo whatever the operation just did. So if something is times 2, to undo that, you would divide by 2. And then let's go back to something, like I said, earlier in the year, we knew additive inverse. That was, we thought of it as the opposite. It was the same distance away on the number line, right? But it was in the opposite direction. But the big thing that it did was that it added to 0. So an example for that would be like 6 and negative 6. Well, if you take 6 minus 6, you get 0. Okay. Well, what is a multiplicative inverse? Let's think about that for a minute. What do we see here in the beginning of this? Multiply. So if we're thinking about what is the opposite again, but this time we don't want it to go to 0. We want it to equal 1. So it's what you're going to multiply to a number that will end up, it will multiply to 1. So think about it like, let's see, if I have 2, the multiplicative inverse of 2, what can I multiply times 2 to get 1? Well, I'm going to multiply times 1/2, right? What if I have 1/4? The multiplicative inverse. What do I multiply by that to get 1? Well, that's 4, or 4 over 1. Okay, so I can see that we're going to be using all of these types of inverses, the additive inverse, the multiplicative inverse. We're going to be doing those inverse operations. Okay, so let's try. What strategy are we going to use to do this? Well, let's start off by saying that to solve, we want to get a single copy of x on one side of the equal sign. And how are we going to do that? We're going to use the inverse operations. So step 1 and 2 all kind of together. We're using the inverse operations to get x alone on one side of the equal sign. So let's start with that. So right now I look at this and x is not alone. X has got this plus 4 next to it. So I want to get rid of the plus 4. Well, what is the inverse operation of adding 4? It is subtracting 4. Okay? But here's the thing about this is you have to keep it balanced. So here's the structure that I like to use because what you do to one side of the equal sign, you have to do to the other. So I like to do it. And you'll see some teachers that maybe draw a line down to remind us where that equal sign goes, where that balance point is. But if we notice, I want you to notice that negative 4 and positive 4, when we combine those together, those are additive inverse of each other. So they add up to 0. So basically, they get rid of each other. We might think of it as canceling out, but remember that when you're canceling, when you're adding and subtracting and you're canceling, you're really just adding up to 0, which is what we want because now that's gone. That is added to 0. We don't have to write that anymore. The only thing left on the left side is a single copy of x. And on the right side, we've got 12 minus 4 is 8. Okay, so how do we know if we're right? Well, the way we know we're right, we can always plug that value in to see if it makes sense, if it makes the statement true. So instead of x, I'm going to write 8 plus 4 equals 12. Okay, now let's look at just the left side. 8 plus 4, well, that is 12. And then on the right side, I didn't change anything yet, so it's just 12. So what I'm left with is a statement, 12 equals 12. Is that a true statement? It is. That's how I know that this is an accurate answer. Okay, now let's take a look at the next one. I want to get x alone on one side of the equal sign, but right now, there's a minus 12 attached to it. So the inverse of minus 12, or the additive inverse of a negative 12, is a positive 12 or a plus 12. What I do to one side, I have to do to the other. And remember, you could draw a line down there if it helps you remember. You don't have to. But here, negative 12 and positive 12, they are each other's additive inverse. They add up to 0. So that goes away, basically. We don't have to write plus 0. That doesn't change the value of anything. So on the left side, we have x. And on the right side, we have 10 plus 12, which is 22. And how do we know if we're right? Well, we can always plug it into C. 22 minus 12 equals 10. Well, 22 minus 12 is 10, and I haven't done anything to the right side. It's still 10. 10 equals 10 is a true statement. Therefore, I know that this is an answer to that problem. All right, now let's look at these last two. Here we're dealing with, in this first one, we're dealing with multiplication. So we've got 2 times x, and we want to have just a single copy of x alone on one side, but right now we don't. We have 2 copies, or we have 2 times x. So to get rid of a 2 times something, we're going to divide by 2. And remember, what I do to one side, I must always do to the other side, otherwise it will not maintain its value. So 2 divided by 2 is just 1, or a single copy of x. 14 divided by 2 is 7. Again, I can check that. 2 times, instead of x, I'll put 7 equals 14. On the left side, 7 times 2 is 14. I haven't done anything to the right side. It's still 14. 14 times 14 is indeed a true statement. I know that's an accurate answer. And then finally, let's see an example where we're dealing with division. So right now, x is not alone. X has a divided by 2. It has a divided by 2 there. So if we're using an inverse operation, we want to, remember, we're going to cancel that out. But to cancel it out, we're going to have to find the multiplicative inverse, or that thing that multiplied together with it gives us 1. Well, divided by 2, I'm going to say what I want to do is take it times 2. There's a couple ways to write this. Here's one way to write it. Times 2. So let's think about this. If I have x divided by 2 times 2, or 2 over 1, I could follow my multiplication rules and multiply straight across, in which case I would get 2x over 2, which reduces down to x. So did that get rid of it all? It did. So I know that that times 2 is going to work. I've got x on the left side, and then 4 times 2 is 8. Okay? So if the whole just kind of inverse operation doesn't make sense to you, work it out like that. It'll help. And let's see if that's accurate. Well, instead of x, I'm going to say 8 divided by 2 equals 4. 8 divided by 2 is 4. I haven't done anything to the right side. It's still 4. That is indeed a true statement. So 8 is a value for x. Okay. I'm going to give you guys a few minutes to work through these on your own. I think what we'll do is let's just take a minute. You can work these out on and record your answers on Edpuzzle, and then I will come back through with the answers so that you can check your answers. All right, hopefully you've had time to go through and work each of these. I'll go ahead and work them out so that you can compare yours to mine. I'm going to do the opposite, or the inverse of plus 5, and get x equals 6. Right here I've got a positive 4. A positive 4. What is the additive inverse of positive 4? It's negative 4. What is the additive inverse of negative 1? It's positive 1. Again, what is the additive inverse of negative 4? Okay, here. I want to undo a times 6. So I'm going to divide by 6. I want to undo a times negative 2. So I'm going to divide by negative 2. So it doesn't matter if it's positive or negative. That goes to 1. And then on the left side, 18 divided by negative 2. Don't forget your rules about that. It's negative 9. Okay, now I want to take a second to look through this next one. So this next one says negative 1/3 times x. So what I could do is I could do the opposite of times it, and I could divide by a negative 1/3, right? I could divide by negative 1/3. But I want you to remember, when we divide by a fraction, what are we really doing? We are going to multiply by the reciprocal, right? Reciprocal. I'm horrible at spelling. So what is the reciprocal of negative 1/3? Well, the reciprocal of negative 1/3 is a -3, or -3/1. So I could write it like it is there, or I could write it, another way I could write that is, I could say, well, to undo that, I'm going to take it times -3, and this times -3. So a -3 times a -1/3, that gives me just a +1, so it's an x on the left side. And a -3 times a -18, well, that gives me a positive, it gives me a +54. And then let's do the same thing with the next one. So the next one, what is the multiplicative inverse, or that reciprocal, basically, of 1/4? And you know what? Let's take a minute to look at that. The reciprocal, what is the relationship between the reciprocal and the multiplicative inverse? Well, the multiplicative inverse and the reciprocal, they both multiply to 1, right? So let's look at that and say, well, what is the multiplicative inverse of 1/4? Well, it is 4. So that means we want to take both sides times 4. So 1/4 of 4 is just 1. I've got x on the left side. And then a -6 times a +4 becomes a -24. All right, so to recap, we're going to solve equations by, we're going to be solving equations by getting a single copy of x, or whatever variable, a single copy of the variable alone on one side of the equal sign, okay? So you haven't solved it if you've got an x on both sides. We have to have it just on one side and a single copy of it. And how are we going to do that? We are going to, and by using inverse operations. So remember, those inverse operations kind of undo or take you back to the beginning. All right, so that is solving one-step equations in a nutshell. There you go.